Yeah, my name is Serhii, and I'm from Booking.com. And today I was expected to speak with my colleague Shakruk.
Sorry, can you talk a little closer into the mic? Thank you.
Is it better now? Okay.
A lot better, thanks.
My name is Serhii, and I'm from Booking.com. So today I'm going to talk about how we use GraphQL to scale access in service-to-service communication. And first, I'm part of a team who is providing horizontal capabilities to manage data access, so it makes sense for us to work on the topic. And I'm here with Chris. He is part of a team owning overall GraphQL adoption in the company. And before I get into details, I would like to set two contexts. One is a business perspective context to help you understand why we needed the solution. I'll be talking in a minute. And second one, it's a basement of a technical context where we would like to evolve from. And speaking about the booking story, and to cover the first part, founded in 1996 as a small startup with a guy who wanted to connect Dutch travelers to places they would like to stay through online booking platform. And the fun fact may be relevant to this auditorium, that Booking had international following from the beginning. In 1999, 30% of our reservations were actually coming from United States, and due to the fact that internet was more established and had a better speed in comparison to what we had in Europe. And through the years, the startup grew steadily in the amount of employees, local offices, localized content, but also services we provide and our platform and applications. So today, Booking.com is one of the world's leading online travel platforms that connects customers to a wide variety of choices to stay, but also experiences and attractions and various transportation options like car, flights, taxis. So it's not anymore one product company that provides accommodation, but it's rather providing a holistic experience for users with multiple verticals. And as a data provider team, we've been thinking how we can scale data access through all of them. So in that case, a user would actually get this experience. So our mission is to make it easier for everyone to experience the world. And as we know, the most of frictions is not coming only from accommodation, but also from all other verticals. So we wanted to connect all of them through efficient data access. So what we do for travelers is basically we want to enable them to book everything we provide from one-stop place, which is going to be our platform. From another side, we all rely on data we collect from partners, and the partners provide us what services and they provide in the accommodation. So that's our vision for future. We want to become one-stop solution where users can book all aspects from their travel, starting from flights or taxi, or it could be car rental. It could be even a package trip, and that's all required, all good data access through all verticals. And at Booking.com, we always leverage technology to make it happen. But the thing is that we don't experiment with technology for its own sake, but we would rather use it to solve user problem. For example, it can be removing friction, or it make user life easier. And I think our search result page is a great example of that. Probably most of you are guys familiar with that, and you can use it to find the accommodation and where you would like to stay. And yeah, that's in order to load this page, it would require to query multiple databases. And in that presentation, I have 4, but in reality, it would be hundreds of them. And as we all know, maybe from a system design interview or from your daily work, that we cannot just load all of them in real time, but because first it would be latency inefficient, it would take a lot of time to run these queries, but also it would be cost inefficient because we serve billions requests per day, and for each of them, if we would need to run hundreds of database queries, it would be really cost expensive. So, of course, it would require us to rethink about solution. To make it search result page latency sensitive, we would need to prepare data. And what we normally do, we do materialization, where we request all this data in the background and we put them into some persistent state which is optimized for the page. We could do it in a periodical manner, maybe once in an hour, or we can connect it to capture data and change stream and rematerialize data as soon as update happens. Back till last year, our architecture was like that. Basically, we had search result backend, which is a monolithic component which consists of two main threads. One is a request handler that been serving user request and resolving user search criteria. And the second one is update consumer, which is connected to update stream, get data, and put this data into pre-materialized state. So with that setup, request handler can use this data in memory. It's RocksDB database, which is a disk and memory intensive, but it also can provide low latency, so we serve requests as fast as possible instead of going to all of these 100 databases. And from another side, we also had a materialization component, which used to be a monolithic service. Yeah, we like to have monolithic services, which we would do all dirty work and retrieve data from these 100 databases. To make things even more complex, this old database has been owned by multiple teams across the company. And materialization component would retrieve data from all of them, put them into destination serialized blob, and detect if change is happening. We put data into update stream, and then search result backend can consume that. So the thing is that this was the only one materialization component we had, and it's being used by multiple pages, by multiple consumers, meaning that the schema we use growing and growing with the time, because every new consumer would like to have additional data on their page, and which might not be relevant to other pages. As a result, we ended up to have a schema with it's like an object with 1,000 of fields, where only few of them is relevant to each consumer. As a result, a lot of irrelevant update been coming through the stream, overloading other consumers. So to overcome that, to summarize what we had with that setup, first of all, we didn't have no separation of concerns, meaning our business logic and data retrieval were mixed in one materialized component, and it was really hard to decouple. Another problem we saw is ownership boundaries, which was not respected. From this perspective, in the materialization component, we've been retrieving data, raw data from each database, and we were not respecting basically domain boundaries. Moreover, with time, it was very difficult to maintain context about each database, and we couldn't anymore deal and retrieve data properly. And last one, I already mentioned it a bit, is a monolithic schema which been used for multiple clients, which grew with the time. It means that we keep growing our objects and blobs that we serialize, but also we create additional load on network, for example, to transit this data. And yeah, here is coming GraphQL. GraphQL is not new to Booking. I think starting in 2019, Booking started his journey with GraphQL. And the first case we used to modernize our stack and decouple front end and back end. And until recently, it was the only case to provide front end to back end interoperability. So, and yeah, we had a problem with materialization, and we've been thinking how we can solve it. So the first thing which came to our mind, we've been using a materialization pipeline, and typical data pipeline consists of three main aspects. It's a data retrieval, data processing, and then putting data into destination, or basically resulting object, right? And we had in-house built pipeline libraries that consist of multiple stages. Each stage was doing basically retrieval, processing, and filling up some data in a global schema, right? So from this perspective, it actually rings a bell because it's kind of similar how GraphQL executes its request. It retrieves data, processes data, and then put path into the schema. So from another perspective, we saw, okay, we can use GraphQL, but there have been always a concern that GraphQL is not very efficient in service-to-service communication due to serialization and deserialization problem. In comparison with protobuf, for example, we saw a lot of benchmarks that protobuf is more efficient. But if you're talking about materialization use case, latency and additional delay GraphQL bring to us was not very critical, because usually it's a background process that is disconnected from a real-time request and does not impact user experience. So for trade-off for us was kind of very simple. We had to deal with high latency, which is not a problem, but instead we get a lot benefits. For example, we got better observability. As data owners, we could understand which of our fields being used and which not. We also get a unified GraphQL API, which we could share across verticals. So basically, each of them could access data in the same way. And so our change was to materialization component, and we came up with this next architecture. On the low level, you can see we have a data service. Actually, it's not one, but it's multiple data services, which consist of API and data underneath. So when we came up to data owners, we put them in a place where they had to resync their data, because previously they've been exposing raw data. Right now, the GraphQL by design requires them to come up with a schema. So as a side effect of that, right now we have a better overview of our data, but also we expose data not as a raw, but more like business-specific models. So data service has been created, and each of them been owning own subgraph and publishing subgraph to Federation Gateway. Federation Gateway been combining all subgraphs and publishing result as supergraph to each of materialization component. We have multiple of them. Each materialization component was dedicated component to each application that does own materialization. So on the other side, when a materialization component need to query data, it can only retrieve data specific for this application, and the Federation Gateway would handle data fetching from downstream data services. So now the architecture looks like that. Instead of having two monolithic components, we've broken down everything to multiple microservices, where we separated business logic of materialization from data retrieval. materialization component could own queries they execute in a Federation gateway and then put the result into pre-materialized data. On top of that, it could consist of API service, which would serve materialized data to search result backend. It also helps us to set clear ownership boundaries and responsibility boundaries. As you can see, we have subgraphs and data separated from others, and each of them being owned by dedicated team, which cares only what schemas they expose. Materialization part will also owned by a team who own search result application, and they fully understand what's underneath and what data is being materialized. And materialization gateway component is being owned in a central way by a team who is providing GraphQL as a capability in the company. So through this setup, we could now scale materialization. We could scale materialization. It's not like one component we had at the beginning, but rather each application can materialize what they want. For example, search result page is only interested in main photo and facilities to build this small carousel items on the search result page. And the accommodation page requires more comprehensive content to build like a hotel page view. So they both only cares about data they want to retrieve. From data owners, there is also benefit because they don't have a very complex dependency graph, but they rather care about schemas they expose. And materialization component also take care of complex schema evolution or orchestrating the data queries. So this way we can run everything in isolation, and we can scale this materialization to as many verticals and application we need. So as a result of that, we managed to improve our ownership boundaries because we came up with microservice architecture where every data domain exposes API to reach their data. We also tested that GraphQL is pretty good to some cases of service-to-service communication where latency is not critical, but you want to get higher observability, but also centralized GraphQL endpoint to retrieve data. And with all of that, we set up a platform where all our verticals is the flight, cars, accommodation, taxi, and attraction can benefit by materializing for their own use cases. And as a part of that, we also improved our overall infrastructure. For example, search result backend, it used to be a monolithic application with RocksDB, which makes this component bare metal because it's stateful. If we remove RocksDB, then we could containerize this application and put, for example, into Kubernetes. And that's basically it. I also have a reference to another speaker who couldn't come today. And yeah, thank you for listening. Maybe you have questions. Does it make sense, all this approach? Yes?
I'm curious which part of notification, if there was service-to-service communication, because I saw mostly client-driven service. So how do you handle communication between services? Is it all through that main, what is it called, materialization platform? Do they all go to that?
Yeah, so in our case, we are not talking about front end at all. So front end is talking to search result backend to get data. And we have materialization federation. Actually, we have two federations. One is to separate front end and back end, and another one is basically to execute this bulk queries to fetch data and for materialization cases.
If you guys have questions, it's best if you talk in the microphone, if you want to grab it.
So I have a question. The architecture that I have at my firm right now looks very similar to this, a similar use case where we have products that users are searching for, and we have dynamic data like availability or pricing that we need to be able to sort and filter by. And what we're missing, I think, is the front end that we have talks directly to the box that's labeled Materialization Federation Gateway, and there's nothing in between. And so we basically run into a problem where there's nowhere for us to do all that filtering and sorting. I'm just wondering, like, how what's happening here in the Materialization Federation Gateway? Like, are these when the front end's making a search result to the back end? I see that it's making a request to this pre-materialized database.
Yeah, and that's where request ends.
That's where the request ends. Okay.
Yeah.
And so this Materialization Federation Gateway and the search results materialization service, that's kind of building data that can be searched more easily by the front end?
Yes, that's correct.
Okay.
And it's not how the whole request goes from front end to data layer. It's that the diagram contains two basically processes. The top one is a background that's happening on a predictable manner or when change happens, and it populates this data into pre-materialized data. And then user request goes, as I said, we already have another federation on top of that, right, between this mobile phone and the search result backend. So the request goes to search result backend, which resolves it from pre-materialized data.
Awesome. Thank you.
One other thing to consider here is all this is much more static data. So things like price.
So one thing to consider here is this is all very much static data. So things like availability and pricing information, that still goes through Federation, the consumer Federation, but that's not going to go to the materialized data API service because that's real-time data. This is more, as Serhii said, reviews and descriptions and things like that. They don't update super often.
How often do you?
We have two ways of updating. It's either 1 hour in overall, but it could be based on a change happening because we have many of the data domains exposing CDC. So we know if this materialization component knows if any change has happened to trigger materialization. And yes, we use Kafka topic. And the benefit of this architecture is that previously we had only one monolithic component with predefined materialization time. It's been set first 8 hours, then 1 hour, and all other consumers had to agree with that. There was no option for them to rematerialize something faster or sooner. Right now, when each materialization component is dedicated for your application, if you want to rematerialize only small piece of data you need, you can do it as frequent as you want. You don't need to rematerialize everything, and that's where 1 hour came up, because rematerializing whole blob with 1,000 of fields, it's not something you can do every minute. Do you guys have more questions? Yes?
When you're materializing, thank you. Yeah, when you're materializing, do you make one query from the Federation Gateway across all subgraphs, or do you make individual queries of the subgraph?
So materialization service create a whole query of data they need.
They can go across the entire subgraph, all of them at once?
Yes. So
Okay.
it creates one query that goes to gateway,
Right,
and Federation decide how to execute it across subgraphs.
right, right. So I wanted to see if you can share some experience of if certain subgraphs time out or they have different SLAs, how do you coordinate with those Or is it one team that owns all of the subgraphs?
No, it's a different teams,
Yeah.
and well, we have very relaxed SLO from this perspective because again it's a background stuff, and it's always happened in a big bulks. So yeah, we're not restricting at least for now subgraphs to be under certain threshold.
Right, right. Okay, thank you.
It may something to come.
Perhaps it's the nature of the data. If you're acquiring from a point of view of one time, maybe some photos or some reviews may not be available for the room that's available. So how do you? I'm curious how you coordinate that the downstream data sources are having the data for your query too. Or
So-
do you get any health checks to say the photos aren't available as of this moment?
We have comprehensive monitoring, of course, but it's more on request layer, if request was successful or not. What we'd also do to prevent the situation, we put a limit. For example, materialization service cannot request more than 1,000 hotels in one query.
Okay.
So through this way, we can have it within meaningful time frame.
Right. Thank you.
Okay.
So one thing that we're struggling with trying to implement something similar to this is just the amount of data that we need to aggregate into kind of this pre-materialized data. And our initial thoughts were that using GraphQL or just going over HTTP to get all this data into a place where we can aggregate it wouldn't be the most optimal approach. That's not what you guys have found, it sounds like.
I think this approach is actually improving the situation because you can have this materialization per use case. So I'm not sure about your use case, but probably you can break it down into smaller materialization blobs. Let's say you have 3 pages, and instead of materializing everything for application with 3 pages, you could materialize it for each page independently, and then each of blobs of data would be smaller, right? Or did I understand the question correctly?
I think so.
That's something we had at the beginning, like that. So we had one component, one materialization component, which been materializing for 50 different applications, and because of that, the schema was huge, and the data was also because of that huge. And on this diagram, I have only search result backend, but in reality, it's not only search result backend, it's a accommodation page backend and many other pages have been consuming this data. And actually, some of them had need only intent fields, but they had to request the whole blob of data.
Thank you.
All right. Is there any other question? Well, I will summarize. Think about that. It's alternative approach, I would say, to use GraphQL in comparison to where we say front-end retrieve data from backend. It could be maybe more cases where you need to enrich your data in the background or asynchronously. Then GraphQL actually provides a good observability to your data, but also it provides a schema, so you can use it. Right. Thank you for listening to me.